Hi there. Well, this is going to be our last section that we're going to do in this class, and it deals with polynomials. And I wanted to introduce this idea to you, combining polynomials. What are they? Different parts, so that when you get into your other classes, it may not be as new. So again, this is just kind of touching on the basics of polynomials, and we're going to be adding polynomials and subtracting them, and it's combining like terms, which is something that we've done before. Maybe not, with these, with cubes and with squares, but we have kind of looked at this with our variables. All right, so what we have is we have a polynomial here, and let's see, okay, this polynomial here, let me get all these straightened out, sorry about that. All right, a polynomial is made up of two or more terms. Now, each of these groups right here, each of these is called a term in the polynomial, and these terms are separated by plus or subtraction signs. Now, you can look at each of these terms individually. If we look at the first term, let's talk about that first term. That number in front, this right here, is something we've talked about before. It's called the coefficient. So this is also a good review for the final. And I'm not going to ask you to define a polynomial, define a coefficient, but these are words that you need to understand so that if you're reading directions, you know what they want or what to do. Here, the coefficient is 4. So the coefficient is the number in front. Coefficient, it's one of those rule breakers in your English, but the coefficient here is 4 in the 4x cubed. The exponent is 3. It does have some significance, and we'll talk about that here in a minute. But right now we're going to talk about the coefficients. Now, when you're finding the coefficients, you look at the individual terms. The coefficient here is a -5. So we have there's another coefficient, -5. The coefficient here, which we've kind of talked about, is a 1. It's not there, it's a 1. And the coefficient here is a -12. So I want you to remember that if you have this subtraction in front, you do need to include it as part of the coefficient. So it is a -12 and it is a -5. So these 4 are the coefficients for these 4 terms in this polynomial. All right. Now, this power here, the degree, sometimes they want to know what's the degree of the polynomial. The degree of the polynomial is the highest power of your polynomial. And in this case, it's a 3. All right, so our degree is 3. And the degree has significance in the shape of the solutions when you graph them. What type of a curve is it, or is it linear? So this highest power has everything to do with the shape, the basic shape of the graph or of the solutions for that polynomial. So the degree is 3. We have our coefficients and the degree is 3. Now, none of these terms, because we have the 4 terms, are like terms. So there's nothing really you could do as far as simplifying it any further than it already is. And we're going to be adding polynomials where you'll need to simplify or subtract. Okay, now looking at this is also a polynomial here. Okay, this polynomial has 2 terms. And if you have a polynomial with 2 terms, you can call it a binomial. All right, you'll hear that term in your other classes. It's a binomial. It has 2 terms. The coefficients are 1 and 5, and the degree is 2. All right, now you can also have maybe 3 terms, and this would be a trinomial. Okay, you'll hear that in your other classes. The coefficients are 1, 6, and a -10. and the degree of this trinomial is 3. After a trinomial, we just call it a polynomial. We don't have any special names for it. If it has 4 terms or 5 terms, we just generally call it a polynomial. But these, if it has 2 terms, a binomial, and you could have a subtraction there as well. It doesn't always have to be an addition. It can be addition or subtraction that separates out these terms. And then you can have a trinomial with 3 terms. And again, the binomial doesn't necessarily have to have a 2 here. You know, another example of a binomial would be x cubed minus 8x. Okay, that's a binomial. All right, you've got 2 terms. Another example of a trinomial, 6x to the 5th minus 4x squared plus x. That's a trinomial. You can't simplify that. The terms are not like terms, and we're gonna look at that here in a second as we look at some of these examples. But I just wanted you to understand what is a coefficient. So the coefficient here is 6, -4, 1. Those are the coefficients, the numbers in front. The degree of the polynomial is 5. All right. The degree of this polynomial is 3. The coefficients are 1 and a -8. All right. So now we're going to look at some examples. It'll be similar to your homework. We'll start with this one. We'll start with number 5 here. So if you're asked to add polynomials together, they may have parentheses around the 2 polynomials that you're adding. I happen to be adding a binomial with a trinomial. Now, because you're adding, you don't have to have the parentheses. You can just drop the parentheses. You don't have to do anything with what's inside. All right, so because it is a plus sign, I'm going to drop these parentheses. I'm going to rewrite it without them. And then I'm going to look at the individual terms, and I'm going to combine the coefficients of like terms. Now, when I say like terms, it means that the variables and their exponents are exactly alike. So here we're going to start with the highest power, which is this one right here, the 6y cubed. The y cubed is the highest power. We'll start with that one. I have a 6y cubed and a -2y cubed. Those are like terms because the variable groups match. So it not the coefficients in front don't have to match, but the variable and the exponents have to match perfectly, which means we'll have 6y cubed and a -2y cubed is 4y cubed. You don't add the exponents, and that's one mistake that I see students make is they want to add the exponents and get a 6 here, 3 and 3. But remember, we don't add exponents unless we're multiplying, but we're not multiplying, we're adding and subtracting these. So you don't change the exponents. You just look at the coefficients in front. So we have 6y cubed and a -2y cubed is 4y cubed. All right, that takes care of that. And sometimes it's kind of nice to mark them off so that you know you have used those. Okay, the next looks like we have a 4y. Okay, I don't have a y squared, so we'll just do the 4y and a -5y. These two are like terms because you have the same variable with the same exponent of a 1. We'll add the coefficients in front. 4 plus a -5 is a -1y. I'm not going to put in the -1, all right? So that takes care of those two that were like terms. Now the 9, okay, there are no other constants just without a variable. So the 9 has to stay by itself. And you're done. So we combine these two. We ended up with a trinomial, all right? The coefficients of the trinomial are 4, -1, and 9. And the exponent, or excuse me, the degree is this exponent of 3. So the degree is 3. All righty, okay. Let's go ahead and look at number 6 and combine like terms. You don't need the parentheses because of the plus. So you can just drop them and you combine your like terms. So I'll copy this over without the parentheses. Minus 10x cubed minus 8x to the 4th plus 4. Oh, wow. Okay, well, just copied that over. I want to make sure I copied it correctly. Sometimes I transpose numbers wrong. All right, looks good. All right, we're going to start with the highest power of x to the 5th. So we're going to look here, and we're going to look for another x to the 5th. And there aren't any. So that means we're going to lead off with 7x to the 5th. There's nothing we can combine it with, so it'll stay there in our answer is just 7x to the 5th. Our next highest power is that x to the 4th here. And looking at this, are there any other x to the 4ths? I don't see any other x to the 4th power. So it too has to stay by itself. I'm not going to combine it with anything else. Okay. All right, our next highest power is x cubed. All right, x to the 3rd. So I'm going to look at it and see if I have any other x cubes. No, so that one too has to stay by itself. All right. Now we're to x squared. So I'm just going down in power is all I'm doing with x, with the highest exponent on down. Squared. I have a -1 x squared and a positive 4x squared. So I can combine those two. The variables and their exponents match perfectly, which gives me a 3x squared. 4 and a -1 is 3. That's great. That takes care of our x squareds. Next is the x to the 1st. That looks like my only one is a minus x. Nothing to combine it with. It'll just stay. Here I have a 6 as a constant, no variable with it, and a -1. So I'll combine those and get +5. That is your answer. You don't have anything that long in my math lab. It takes a while to type those in. However, this is a polynomial and it has a degree of 5. All right, so great. Let's look at some more examples. Let's look at what happens if rather than a plus sign, rather than a plus sign, what happens if I have this negative outside of the parentheses? Well, we've talked about this before. If you have a negative outside the parentheses, this is a great review. This right here changes the sign on everything on the inside. What's actually happening here, that right there means -1 times what's inside. These two mean the exact same thing. We'll be taking the opposite. When you multiply by this -1 times this, -1 times this, it changes the sign. So we'll have a -7x cubed. All right, so this is going to change all their signs. A negative times +3 is going to be a -3x. And this times this is going to be a +2. So you can either think of it as multiplying by this negative or the fact that it takes the opposite of what's inside the parentheses, excuse me, only. So it'll take the opposite of what's inside. This is your answer. Okay, you cannot simplify that any further because none of those are like. This is an x cubed. This is an x to the 1st. All right, and this is actually an x to the 0 for that one. All right, so let's look at this number 8. What we're going to do is rather than thinking of it as a -1 times this, a -1 times this, we're just going to take the opposite of what's inside. So it'll become a positive a to the 6th, a positive 8a cubed, and a negative 2a. Now, when I do that, notice I drop the parentheses. So when you do take the opposite of what's inside, the parentheses are dropped. All right, and we're going to use this idea in subtraction. All righty. So that's all you do is just take the opposite and you're done. So let's look at some with subtraction. Here I've got some examples to choose from. Probably not going to do the one with the fractions. We'll see. Okay. All right, rather than a plus sign like we did on the other side, I now have a subtraction between the two. So you can't just drop the parentheses. You're going to have to do something before you can drop the parentheses. In front of this, there's not a negative here. If there were, you'd have to take the opposite, but there's not. So I'm just I can drop the parentheses. There's nothing in front here. 12b squared plus 5. But here, in order to drop the parentheses, I can change this to addition. All right, change that to addition and then change the sign on everything inside. This will become 9b squared. That becomes a positive, and that becomes a -6. All right, so this subtraction in between becomes a plus, and then you change the sign on what follows. And we've done this earlier, but we didn't have like a b squared or an x squared. We just had an x. Okay. All right. So now that you've done that, you can combine your like terms. And looking here, we've got 12b squared and a 9b squared gives you 21b squared. All right, not b to the 4th, b squared. Only time we'd have b to the 4th if I were multiplying those two together. And then we would end up with 108 b to the 4th. But we're adding them. Excuse me. So now what we're going to do is we'll look at the 5 and the -6 and combine those. And that gives us a -1. And that's your answer. Okay, you ended up with a binomial. Already you have a coefficient of 21 and -1. And the degree is 2. Alrighty, so you do, when you have this right here, you make it a plus, and then you change the signs following, right? Let's, we'll save that one if we have time. Let's look at number 12. You know, number 11 is done the same way, but you know, you could use your calculator because you've got these, you know, even though you may not need, if you, to do that, you could use your calculator dealing with these decimals here. But the main idea is this guy right here. How do you handle that subtraction? Okay, in the first parentheses, it stays. -11x. So that there's not anything in front here. Now, if there had been a 2, I would have multiplied the 2 through. If there had been just a negative here, I would have changed all the signs. All right. But here, I'm going to change this to a plus and then change all of these signs here. So that becomes a -5x cubed. Inside, it was a positive. Now it's going to be a negative. Let's see, that'll become a minus. That will become a plus. And that will become a plus. And now you combine like terms. Now I want to look at this right here. Some people may just use a subtraction right here instead of plus and negative. You can just use a subtraction. All right. Either way. Let me erase that and let me show you. Rather than plus the negative, you can have the subtraction. Okay. You know, either way, that 5 is a negative. So you either go plus the negative or you have the subtraction. Now let's go ahead and combine our like terms. Let's see, we've got cubes. I've got a cube here and a cube here, and that's it. So I'll combine the coefficients in front. 8 and a negative 5 is 3. Looking at our x squareds next, I've got a negative 3x squared. You do need to include that negative. Negative 3x squared and a negative 1x squared. It's a negative 1 and a negative 3 is a minus 4x squareds. Okay, when you combine those. X to the first, I have a negative 11 and a positive 17, which means when I combine those, it looks like I'll have a positive 6 x's. Okay, when I have these two, give me a positive 6. And it looks like we have a minus 6 and a positive 4, which gives us a minus 2. And that's it. There's your answer. All righty. So what I'm going to do is we're going to look at another one just to get used to that idea of that subtraction there real quick. Practice it, and then we have one other idea, and it looks like that'll be it. All righty, so I wanted to come up with one more that had some pretty sane numbers in it. I want to talk about this minus here. X minus 1. All right, let's see what we got here. Okay, there's nothing in front here. So that means we'll just drop that parentheses. Now here, this is going to change that to a minus. And so this is kind of what I was telling you before. Most of the time you'll see this positive just written as a minus 5x squared rather than plus a negative. All right, I just wanted you to be aware that this is more conventional to write it here. So that is the minus, that becomes a plus, and that becomes a plus. All righty. So we have just taking the opposite of what's inside is what that guy is doing right there. Whether or not you have plus the negative, change it to a plus a negative, or just keep it as a subtraction. Now, when we combine our like terms, we've got x squared. So that means minus 3 and a minus 5 is a minus 8x squareds. Positive 1x and a positive 1x is a positive 2x. All right, 1x and 1x is 2x. Negative 1 and a positive 1 is 0. So it looks like we ended up with just a binomial. Coefficients of a negative 8 and 2 with a degree of 2. All righty. So if you still have some questions on the subtraction, let me know. Or combining the like terms. And all I can say is just please make sure that you're not adding exponents here. That's when you're multiplying. If you multiply those together, that's when you're going to add exponents. But if you're just adding or subtracting the coefficients in front, you don't do anything with those. All righty. Okay, last one has to do with some substituting in some numbers. Yeah, I think I can use this piece. So what they're going to do is they're going to give you a polynomial, and they're going to give you a value for the x and ask you to put that in to see what it would be equal to. So we're going to evaluate the polynomial, and again, they'll give you the number here. So we'll put in 5 and we're going to square it. This is kind of a review of PEMDAS. 6 times 5, when they're next to each other, you multiply, plus 9. So all I did was put the 5 in for the x. And now we'll follow our Pemdas rules once you've done that. So you have parentheses. We don't have them. We have exponents here. Let me just write that. Okay, so we have parentheses. which we don't have. Exponents, we do have. Then we'll multiply or divide. Looks like we have a multiplication, and then we'll come back and add or subtract. So our exponent gives us 25. And that's the only exponent we have. Now we can multiply now, get 30 plus 9. Okay. Now doing our addition and subtraction, we have a couple of options here. We can go plus and negative if you want to do that. You can add the positives together, and then that gives us 34 plus a negative 30. Just added those. Oops. 34 plus a negative 30 is a positive 4. Do I have enough room? I'll have to set it over here. Okay. Now, if you wanted to, you could have gone 25 minus 30 is a negative 5, plus 9 is a positive 4. But a lot of times people add all the positives together and the negatives and then combine them at the end. And you end up with a positive 4. Just as long as you're doing your adding and subtracting last. That's the key. All righty. Okay, let's go ahead and substitute into this next one. All right, we've got a negative 5 times, we have 5, our x is still going to be 5 cubed, plus 2 times 5 squared. Now, the reason I'm writing it like this is that you have to make sure that you cube that 5 before you multiply by the negative 5. You have to square the 5 before you multiply it by 2, because I think there are some people that had some issues with that on the test. So again, make sure you do the power before you multiply. All right, just one moment, please. Okay, I had to pause. We have too many dogs. All right, so where were we? They were barking. I had to stop. Oh yeah, this is what I've noticed is that people will multiply these and then do the power. But here you always do the power first and then do the multiplying. Now, when would you multiply before? Is if you had a negative 5x cubed. When it's in parentheses, you would do it first. That's what the P means, do that first. But here, then, so with parentheses, you have a negative 5x, you multiply them, and then you cube them. All right, so that would be the, okay, sorry, I had to pause it again. It's the last one, and I have dogs, and then my husband was, I don't know what he was doing. But anyways, so let me go back over this. Again, if here you would do the power first and then multiply by a negative 5. Now, this is an example of when you would multiply and then cube it. It has to be in parentheses. It has to be in parentheses, or the exponent will come before the multiplying. All right. So again, you have to have parentheses if you're going to multiply before you cube. Here there are no parentheses. It's just the x that's being cubed. And we kind of talked about it when we had that 0 power too, because it would just become a 1, but the negative 5 would stay. Here you would cube and then multiply. Minus 4 times x is 5. Okay, plus 3. All righty. So we're going to cube the 5 to begin with. I think I'll just put it on this other sheet of paper. So when you cube the 5, you get 125 times a negative 5. And I'm just going to go ahead and do all my powers first. Now, because this was in parentheses, I'm going to square the 5 before I multiply it to the 2. So 5 squared is 25. And then I'll come back and do all my multiplication. We'll just follow the PEMDAS step by step. I substituted it in, and now I'm doing the powers. Multiplying these, you get a negative 625. All right, plus 2 times 25 is 50. Minus 4 times 5 is 20, plus 3. All righty. So now I did the multiplying. Exponents, multiplying. Now we'll go back and do the addition and subtraction. So this will give us plus and negative. I'm going to go ahead and combine the two negatives, and then I'll combine the two positives. We have a negative 645 plus 53. I added the negatives and I added the positives together. So it looks like we're going to have a negative 592. Yeah. Is what you come up with for an answer. And again, I just want to caution you, this is where people are going to have some issues. They're going to want to multiply before they do the power. And again, I just caution you against doing that. Only if you have a parentheses would you ever multiply before you do the power. Otherwise, power, multiply, power, multiply. All righty. Okay, now let's practice another one here. We'll change our number to a negative 3, and that does have some significance too. You have to watch that negative when you have even powers. All right, we're going to put the negative 3 in for the x. So we're going to evaluate this polynomial if x is a negative 3. I don't think there's plenty of room. So we'll have 8 times a negative 3 subtract 4. Okay. So I substituted it in, knowing that when they're next to each other, you multiply. There's no parentheses. There are no exponents. So we'll multiply. Multiplying these two together gives us a negative 24 minus 4. This will become a negative 24 minus 24 is a minus 28. There we go, negative 28. And so this is a nice review. We've done some of this before. Last one, we're going to put a negative 3 in for here. So we have a negative 3 times a negative 3 plus. I am going to put the negative 3 in parentheses right there. All right, because you want, when you're putting the negative 3 in, you're going to be squaring the negative and the 3. So if you don't put it in parentheses, especially if you do it on a calculator, if you put it in like this, it will square the 3 and take it times a negative 1. All right, that's what your calculator thinks. So it's a difference. There's a difference between these two. And again, using these parentheses tells your calculator that the negative 3 is it's a negative 3 times a negative 3. Here, the calculator thinks, oh, it's 3 times 3 times a negative 1. It's treating it like these right here. Oh, I'm not sure. I can't put some writing there. All right. So, you know, it thinks it's like this, where the negative is right here. So you do need to put the parentheses around it to tell the calculator that the negative is going to be squared, as well as the 3. All right. So a negative 3 times a negative 3 here is positive 9. Negative 3 times a negative 3, so a negative 3 squared is a positive 9. All right, plus 6. So notice that I didn't put the parentheses around it when I put it into this x with the odd power. It's only if it's an even power. If it's a squared or a 4th power or a 6th power, you're going to have to make sure you have those parentheses around it. All right. Let's see. We come up with all addition. So we have the 9 plus the 9, which is 18, plus the 6 is 24. So that is the only problem spot, is right there, is that when you square the -3, it's a +9. All right. Okay. Wow. I think that's it. If you guys have any questions, please let me know. Otherwise, I'll be opening up these assignments as well as the final. All right. Again, let me know if you have any questions at all. I'd be happy to help. All right. Bye-bye.